Hurry, he'll be here soon!
Another of the devices was a seismometer.
Have you cleaned your room yet?
I can't, Mom. I'm busy.
Thought was at the drill they had left during the
Busy?
DA.
You know he'll be here any minute. Now clean your room.
But, Mom, I'm doing an experiment on chaos theory.
Don't touch that.
Great precision. Unknown expression. An experiment.
It's...
Science rules. Inertia is a property of matter. T-minus 7 seconds.
Brought to you by Co-Winky-Dink, Inc., the probability people.
Hey, is your TV on? If it is, that's great. You're using electricity. But if you're watching the show and your TV's not on... Anyway, what is electricity? I mean, where does it come from? Is it just sitting in the wall waiting for us to use it? Or is it constantly spilling out of sockets and we don't notice it? And how can something so powerful be invisible? Well, electricity is the flow of tiny particles called electrons. And they're not just smaller than atoms, they're actually part of atoms. Take a look at this. It's our battery-powered electrical circuit of science. We're going to run this big light with this big battery. Watch.
Attention, Nile
See, right now, electrons can flow from this side of the battery, through this wire, through the switch, through this wire, into the light, and back to this side of the battery. They're flowing in a closed path, what scientists call an electrical circuit. Now, circuit, that's from an old word for go around. So electrons, right now, can go around an electrical circuit. The flow of electrons is a lot like the flow of water. No kidding. Watch. When I operate this great big water pump of science, water goes through this hose into this box and makes this water wheel go around. And it goes out the other side and through this hose back to the pump. It's a closed path for the flow of water. It's a water circuit. It's just like the flow of electrons through an electrical circuit. Electricity is a very versatile form of energy. The same electrons that are making the light light up are making a motor go around. See, electricity can do all kinds of different jobs, and they're all done with electrons.
The balloon swells because warm air takes up more space. It expands. A bucket of icy water is used to cool the bottle of warm air, but cool air takes up less space. Cool air contracts.
Want to make a duck call? It's easy. All you need is a plastic straw. First, take a straw. Then, flatten out the last few centimeters. I mean, really flatten it out. You want a good crease. Then, cut the flat end into a point like this. Stick this end in your mouth and blow really hard. If you get it right, the ducks will quack back. Try it.
This is magnetic or not. A screwdriver. Magnetic or not. Cold hard cash. Magnetic or not. A levitating train. Magnetic or not. This has been another Magnetic or Not.
getting our headphone mix together so we can go out there and track our hit single Kickstand. With Soundgarden, we're using 48 tracks where you can put each instrument on its own track. You can isolate individual instruments on the tape by soloing them up on the board. On the drum, this is the snare drum. If you want a little more high-end treble to it, it's like on your stereo system at home, you just bring up the high end. If it needs to be a little more mid-range or a little more bass until you get it just right, and you put it back in the track and listen to it, and you decide if that's good or not. You can do guitar. You can do a vocal. Come stand me up. Anything you want. You can add effects to the vocal. This is a doubling effect. You got a juice to fill my cup. Huh? When it's all done, it ends up being on your CD. Slinkies are perfect for showing how sound waves travel through the air. No kidding. Take a look at this. Watch. See how the spring squeezes together and then spreads apart? Well, the same thing happens in air with air molecules. The sound waves make the air molecules squeeze together. And the squeezed together air molecules travel through the air like a wave, just like the wave in the Slinky. It works like this. Think of these air hockey pucks as air molecules. When a sound is made, they bump into each other. Like this. You ready? Hey! Hey! See that? The wave zips right through them, even though the individual pucks or the individual molecules stay pretty still. Now, what happens when the wave hits this wooden barrier? It bounces back, right? And so what happens to a sound wave when it hits something and bounces back? Oh, that's an echo! That's an echo! That's an echo!
Welcome to another great moment in science. The year 1994. Science guy is hot on the trail of heat. Wants to find out what natural convection is. Decides to fly in glider to find out.
Here's the idea. The sun warms the land, and the land heats the air right above it. The air molecules get going faster and faster, and they move farther and farther apart. Then the cool air comes in and pushes the warm air up, and it pushes us up with it. It's pretty cool. Natural convection!
Will Science Guy overcome the natural convection air currents? Find out in the next edition of Great Moments in Science.
It's hot in the summer because we get sunlight head on, and it's cold in the winter because we get sunlight at an angle. The Earth's angle is really important. I'll show you. Get some juice can lids and paint them black. Then set them up like this. One straight up, one flat, and one at an angle. Turn on the light and wait a few minutes.
Which one will be hotter?
Nah.
Okay.
This one's warmer.
Careful. Watch it.
This one's hot. This one's what happens in the winter. We get sunlight at an angle, so it's colder. This one's what happens in the summer. We get sunlight head on. Is that hot or what?
One hot cop who really loses his cool. Johnny Crust.
Who's the thinnest skinned cop in history? Who's burning down below? Whose temper flares with a white-hot glare like a human volcano? Well, it's Johnny Crust, and it's just cool as you please. But internally, subdermally, he's 900 degrees. Johnny Crust, you best not mock. 'Cause listen, bud, he ain't got blood, nor Johnny bleeds molten rock. 6 feet of cop, he just don't stop until he's made to bust. But Johnny's skin is paper thin, yeah, they call him Johnny Crust. He's Johnny Crust, better take his temperature. 'Cause if you ain't learned, bub, you'll get burned by Johnny Smoking Core.
Johnny Crust, coming this fall on the Bill Nye television.
Wet lands soak up floods. Wouldn't bare, dry dirt be better? Well, please.
Consider the following.
Wetlands soak up floods in a couple of ways. First of all, water sticks to water. Take a look at this. Here's a moist or wet sponge, and here's a very dry sponge. When you put them in water, the moist sponge soaks up water a lot faster than the dry sponge. That's because water molecules stick to other water molecules. It happens in sponges, and it happens in wetlands. Wetlands are also where a lot of plants grow, and plants slow water down. Take a look at this. These are our water marble wetland models of science. The marbles are like water, and these pegs are like the roots and stems of plants in a wetland. This side is like bare, dry dirt. Now watch what happens when we lift the gates and let the water flow over the land. Ready? 3, 2, whoop!
3, 2, 1.
See, the marbles on the dry side flowed right through, but the marbles on the wetland side were held back a little bit by the pegs, just like water in a real wetland is held by plants. In real wetlands, it can take weeks for the water to flow out of them. So wetlands slow down floods by holding them back with the roots and stems of plants. Well, thank you for joining me on...
Consider the following.
Here's the story of Johnny Atom, who is everywhere and everything we know. He is solid, liquid, gas, every matter. That's how the phases go.
Here's the story of the same guy, Johnny. He makes chemistry and science really fun. He is all things, he's all around us. He's the atomic one.
Energy and Johnny Atom work together, making all the matter change from state to state. Molecules, compounds, and even plasma. It goes to show you chemistry is really great. He's Johnny Atom. He's Johnny Atom. He's solid, liquid, gas. He's everything.
Let's try an experiment. Perhaps your mother will let you perform this experiment in her kitchen. All you'll need is a toy balloon and a tea kettle of boiling water.
When matter is a gas, a lot of the time you can't see it. It's invisible. But here's a way to prove to yourself and any of our fellow scientists that invisible gas is matter. We'll weigh it. First, take a look at this broomstick balance of science. It's a broomstick with a hole in it. There's a lunch bag tacked to each end. Now we need to make some invisible gas. This is an old trick, but it's a good one. Pour some vinegar into a pitcher. Then add a little bit of baking soda. That fizzing is carbon dioxide gas coming off. It's the same gas that bubbles out of our soft drinks. Even though it's invisible, you can still pour it just like you pour water or milk. Pour the invisible gas into one of the bags. It pours even though you can't see it. The gas is heavier than the air, and the bag on this end goes down. It's invisible, but it's matter. It's in the phase of matter that we scientists call gas. It's a gas! And it's total science.
It's a great moment in communication. This has been another great moment in communication.
Did you know that?
Teeth are the strongest bones in the skeleton. There are 3 bones in each ear: the hammer, the anvil, and the stirrup. There are over 600 separate muscles in the body.
Now you know. Today on the Jackie Smash Show, it's the amazing juggling feats of Yoo-Hoo the Clown.
Jackie, you canceled. Now it's built by the science guy.
And my guest apparently is Bill Nye the Science Guy.
Great to see you again, Jackie.
What do you mean? Have you ever been on this show? He's never been on before, has he?
Yeah, once I think.
Lots of times. Yeah.
Let's cut the small talk here, Bill. I want to talk to you about ears.
Yeah.
How do these things work anyway, these ears we have?
Oh, we have 2 of them, most of us, and I prepared a little demonstration. Let me show you. Sound is vibrations moving through the air like this. The vibrations make air molecules move. The vibrations come down this part of your ear to your eardrum, which flexes like the head of a drum, like this. Now your eardrum vibrates at exactly the same speed as the vibrations of sound. It makes these tiny bones move, and they push on the end of this seashell-shaped tube called your cochlea. Tiny hairs toward the front of the tube pick up high-pitched sounds, and hairs deep inside the tube pick up low-pitched sound. They send signals through your auditory nerve to your brain, and we perceive them as sound.
So, it's all done with vibrations then, huh?
That's right, Jackie, vibrations.
Bye.
This is a cast of a myosaur egg. This is the femur of a 3-foot-long myosaur, and this is the femur of an adult myosaur. It was about 30 feet long. My name is Rebecca Laws. Basically, I spend my summers digging up dinosaur bones. I used to want to be a veterinarian and switched over to dead animals, essentially. This is a baby myosaur skull. It's from a dinosaur that was about 3 feet long. And this is a skull, a cast of a skull from an adult myosaur, a herbivorous. Paleontology is important because we're able to reconstruct past ecosystems and environments. And by doing that, we can compare them to our environment today and help us understand what's going on with our ecosystem and maybe ways we can improve it.
This is Magnetic or Not? An iron butterfly. Magnetic or not? In-A-Gadda-Da-Vida by Iron Butterfly. Magnetic or not? David Hasselhoff. Magnetic or not? This has been another Magnetic or Not.
Hi kids, I'm Uncle Fran. I'm a little ticked off. Sometimes I get mad, but I will always be your friend. Hi kids, today's word is food web. I know it looks like 2 words, but it's one idea. Here's a little poem you probably already know. There There was an old lady who swallowed a spider that wiggled and jiggled and tickled inside her.
Why'd she do that, Uncle Fran?
Because that's the way the song goes, Mr. Raccoon. Understand?
Well, no, I mean, you wouldn't swallow a spider. That's a gross...
She swallowed the spider to catch the fly. I don't know why she swallowed the fly. I think she'll die.
That's so sad, Uncle Fran.
It's just a song about a woman not living in a real food web, Mr. Raccoon.
It's not real?
No, the food web is real, Mr. Raccoon Man. It's swallowing the spider to catch the fly that doesn't work so well. Get it now?
Doesn't make any sense to me, no.
I know something that might help.
Ow!
How's that? You getting anything?
No! I mean, how would... No!
I'll try it again.
Well, no, wait. You know, it is starting to come in now.
Is it?
Yeah.
Yeah, I thought it was.
Yeah,
Okay.
yeah, real clear.
Okay.
Back to this dark.
Thank you. Welcome back. I'm Michaela, and I'm here with my very special guest, Mr. Bill Nye.
Thank you, everyone. Michaela, it's so good to be back on the show, and you are looking fabulous.
Thank you. You too.
Oh, thank you, Michaela.
So tell me, Bill, what are we going to do today?
We have here the ingredients to make virtually anything.
Oh, these are different kinds of atoms.
That's right. These are all the different elements, all the different kinds of atoms in the universe. Now, atoms come from stars. Now, take, for example, our planet. Our planet has a lot of iron and silicon, along with many other elements. And our star has a lot of hydrogen and helium. Now, Michael, that's our hydrogen. Almost lost it there. It's okay, everybody, it's okay. Now, Michaela, you and I are 65% water.
Right.
Now, what's water?
H2O.
That's right, H2O. I have some water here, which I prepared earlier. And the water is 2 parts H and 1 part O. H2O, water.
So with this here, we can make virtually anything.
Well, actually, no. Because in order to make all these atoms, you need the force of exploding stars and billions of years. But brownies, on the other hand, only take about 35 minutes.
And even brownies are made of atoms.
That's right.
Oh, Bill, this looks fabulous. People, it looks fabulous, doesn't it?
Oh, thank you. Here, Michael, you please have the first one.
Oh, thank you. Oh, delicious.
We'll be right back. Thank you.
It's time for Mind Your Manners with Billy Kwan. Today's episode, Forces of Fury.
Nice drink. Yes. Really hitting these babies. I've got the big ball going here. Momentum. Yes. You know, momentum depends on how much things weigh and how fast they are moving.
I don't care, not gonna make it.
No, watch this. Hey, you, Mr. Cueballhead, you just ruined the most perfect shot ever. No, we must fight.
Well, all right, then let me limber up first.
Very nice momentum. You fool, the more something weighs, the more momentum it has. Remember, kids, be like Billy. Know your momentum. Moments in measurement. A long time ago, people used to measure things with their own body parts, like feet. But just whose foot was 1 foot? Later, it was the king who declared that his foot, the royal foot, would be the foot that all feet would be fitted against. It was the standardization of the foot, and it was quite a feat.
We clearance to launch. We are go. 15 seconds.
These are gonna be the fins for the rocket.
11. 10.
My fins are looking pretty cool now.
Ignition sequence start. Engines armed. 5, 4, 3.
Time to launch it!
2, 1. All engines running. Launch commenced. Liftoff. We have liftoff. The tower is clear.
You're made of protein. Protein's the building block of your body. Like bones, skin, tendons, and teeth, they're all made of protein. And you get protein from the food you eat. Now, when you eat things that are made from animals, like milk, eggs, or meat, you're getting what we call complete proteins. Now, complete proteins are proteins that your body doesn't make for itself, but you've got to have. And when you eat fruits and vegetables, plants, none of them have complete proteins. But think about this. If you eat certain plants together, like rice and beans, they have what we call complementary proteins. And the two of them work as a team to make complete protein. Same thing is true of squash and soybeans or tofu. They have complementary proteins and they make complete protein. And here's the thing. In Central and South American cultures, people have eaten rice with beans for centuries. And in Asian cultures, people have eaten squash with soybeans or tofu for centuries. Coincidence? I don't think so. Here, have some complete proteins.
No, that's...
Here you
that's
go.
okay. No, really, I don't... This is Magnetic or Not. An aluminum bicycle. Magnetic or not. More cold, hard cash. Magnetic or not. The planet Jupiter. Magnetic or not. This has been another Magnetic or Not.
1 0 0 0 1 1 0 1 1 1 1 1 0 1 1 0 1. No computers ought to know computers. Computers are just tools that convert information. You ought to know by now, 'cause they're all across the nation. Ought to know computers. They're a complicated set of on and off switches. If one command is wrong, baby, they will have some glitches. Ought to know computers, ought to know computers, ought to know computers. 1 0 0 0 1 1 0 0 0 1 1 0 1 1 1 1 0 1 1 1 1 1 0 1.
Help me out, want you to be my tutor. What's a bit about the mind? And what am I matter to late the night? It's not just a calculator. Your place is a nice navigator. You can be my troubleshooter. Oh yeah, I want to know.
Well, that's our show. Thanks for watching. I gotta keep moving. See ya.
Goodbye now.
See ya.
Bye now.
See ya.
Bye now.
See ya.
Produced in association with the National Science Foundation.
The science guy.